where I'm here with you and I'm going to take some important questions, 300 most expected questions on entire mechanical engineering. This game changer series that we have taken for the entire month, previous month of August, I hope that was helpful to all of you. In that series, we have focused mainly on subject-wise practice of the questions. And you must have seen that in every week, in every particular week, we have practice questions on either thermodynamics, IC engine, fluid mechanics, or applied thermodynamics. Okay, so those practice sessions were subject-based questions, so that if you guys want to have a particular set of basically sessions dedicated only for particular subject. So for the August, if you see the entire August month, I have taken the sessions like that. But in this particular month, I am thinking, because you have done subject-wise practice of the questions, why not this month let's have a mixed practice of questions, where each session will have mixed questions on thermodynamics, IC engine, refrigeration, air conditioning, power plant, fluid mechanics. So all the 5 to 6 subjects that I teach, you know, that will be taken in the form of a session for the entire September month. So first of all, good evening. Once again, welcome to Resultant Je YouTube channel. I hope everyone is in good health and you are following our session, our YouTube channel. And I can see the subscribers on this YouTube channel are 807, which is still in a few numbers left than 1000. It's still, we can say, around 197 students need to join to subscribe our YouTube channel. So I request everyone, those who have joined us and in this session, if you have not yet subscribed to our YouTube channel, please do that. And also you can share this whole YouTube channel with your friends also, so that if they are preparing for some competitive exam like RRB JE, they can also study from this channel. Here we provide both technical and non-technical classes that will be useful for all the students who wants to prepare for RRB JE. Okay, so you can share this this YouTube channel, these sessions with your friends, any student, any known who is preparing for some competitive exam like JE, so that they can also come to our channel, they can also study and get benefited. Okay, so hello Ramjeevan, good evening, welcome to the session. Let's begin today's session. This is my humble request to all of you, that if you have not liked the session till now, please like it, share it, and also do not forget to subscribe the channel and press the bell icon which is next to the subscribe button. Okay, this is my introduction for all the students who have joined me for the first time on this particular YouTube channel. My name is Vikas Sir. I'm a faculty of mechanical engineering, having over 7 years of teaching experience, teaching for different competitive exams like GATE, engineering services, AE and JE exams, which are basically either state exams or central exams, and some PSU exams. So I have experience of all the types of technical exams, and I have done my MTech in thermal engineering, obviously after completing my BTech. Okay, these are the subjects that I will be teaching you. Okay, one more thing I want to tell you, that at Resultant we are currently we are having 3 types of paid courses. One is focus batch, which is only for RRB JE CBT1. But apart from focus, if you want to study only for either CBT2 of RRB JE, then you can only take AIM batch, which is only for technical preparation of CBT2. And we have mission batch, which is a combined batch for CBT1 and CBT2, where you can prepare with us. Okay, so that is all the information. I think you are all satisfied with that. Let's come to question number 1. Which of the following gas power cycles SOM class is also needed? Subhadeep, I think Abhinav Negi sir have taken a SOM session, strength of material session. See, since strength of material is a common subject for civil and mechanical, and Abhinav Negi sir has taken, I think 1 or 2 days back, he has taken a class of strength of material. So you can follow Abhinav sir classes. Okay. Likewise, like I teach FM, when I teach FM, it will be common for civil and mechanical. Okay. Which of the following gas power cycle has in ideal condition thermodynamic efficiency equal to Carnot cycle operating between the same temperature limits? Tell me, which gas power cycle has efficiency operating between same temperature limits. When we say same temperature limits, so within same temperature limits, we are talking about Carnot. And if you see Ericsson, Joule, Atkinson and dual cycle, Carnot is a reversible cycle. So you know that between same temperature limits, if we operate to reversible cycle, then their efficiency will be same. So Carnot is already reversible cycle given. So which cycle will be having efficiency equal to Carnot operating between same temperature? Obviously some reversible cycle should be kept here, and that reversible cycle will be Ericsson cycle. Okay, so efficiency of the Ericsson cycle will be equal to efficiency of Carnot cycle. Why? Because Ericsson cycle is also a reversible cycle like Carnot. Okay, so their efficiency will be same operating between same temperature limits. Clear? Next, the power developed by the engine at the ground level where air density is 1 kg per meter cube is 10 kilowatt. So basically they are saying in this question that we are having an engine which at the ground level, when it is operating at the ground level, it is having the power of 10 kilowatt. It is producing power of 10 kilowatt. At the ground level, when that engine is operating, then the density of the air at that point is 1 kg per meter cube. Now in this question it is being asked, what will be the power developed in kilowatt at an altitude of 100 meter? 100 meter means if the same engine, obviously that automobile can definitely, if it is moving at some altitude, it is at altitude of 100 meter. Okay, so at 100 meter altitude, what will be the power developed? Also at 100 meter above the ground, let's say this is the ground, at the ground level, the power is equal to 10 kilowatt and density is equal to 1 kg per meter cube. Obviously, when you move, that automobile is operating at somewhere, let's say 100 meter above the ground, then at that point density will reduce. How much? Just half. Okay, 0.5 kg per meter cube. One thing you should all know that density is directly proportional to pressure. For air, density is directly proportional to pressure and density is equal to mass per unit volume. And if we are talking about the engine, my friends, in case of the engine, you know the volume of the engine is kept same. The same engine, when it is operating at 100 meter above the ground, obviously density has reduced because pressure has reduced. Pressure will reduce if you go in the upward direction. Okay, so if the pressure will reduce, density is going to reduce, and it is just half. You can see that density was 1, here it is 0.5. Density will reduce, mass will reduce, mass of the charge will reduce, power will reduce. So we can say that power and density is having direct relation. So if the power is density is reduced to half, the power will reduce to half. Very simple concept. Clear? Understood everyone? The class timing of Abhinav sir is also 8 p.m. Okay, I think he takes class at 8 p.m. One more thing, that class is already provided on this YouTube channel. You can check that. He has taken a class on strength of material on the same YouTube channel, and let me just see that. Just a second. Yeah, he has taken class on SOM practice of questions for RRB JE just one day before. Okay, so you can just check that class and you can study from that. All right. So understood, the answer will be 5 because power and density are directly related. More is the density, more will be the power. Density is half, power will be half. So here the power will be how much? 5 kilowatt. Clear? Next question. Consider the following statement regarding dry sump lubrication system. The oil from the sump is pumped to the engine cylinder through oil cooler. Dry sump lubrication system is a type of lubrication system used for the IC engine. Okay, and this question they are saying that in the dry sump lubrication system, the oil from the sump is the reservoir. Sump is a reservoir which is made in the crankcase. It is a reservoir made in the crankcase. The oil from the sump is pumped to the engine cylinder through the oil cooler. With the help of oil cooler, they are saying the oil will pump. Why it will be pumped through oil cooler? No, it is wrong. Okay, oil cooler. Oil pressure varies from 30 to 60 bar. 30 to 60 bar, no, this is also wrong. This is too much pressure. It's not that much pressure. This is also wrong. It is used for high capacity engine. This is correct. Only option 3 is correct, that dry sump lubrication system is used for high capacity engine. The oil is not pumped to the cylinder with the help of oil cooler. It is pumped by an oil pump, obviously. But it's very obvious. Why an oil cooler will be used for pumping the oil, right? So the statement 1 is incorrect. The pressure is also not 30 to 60. It's too much. It's like up to, the pressure will be around 10 to 15 bar. Around 10 bar. It's not up to 30 to 60. That's too much of pressure. Okay, so that is also incorrect. Which of the following statements are true for manometers? Manometers are easy to operate. Manometers do not require frequent calibration. Manometers are made of steel. Which of the following statements is or are true? Matlab, this question can have multiple answers as right answer. Like it can be single answer also. But as you can see from the option, at least 2 answers should be there minimum. Manometers are easy to operate. That is correct. It's a simple tube. It is a simple glass tube and it is just installed in a pipeline. Let's say this is a pipe. Okay, this tube is installed. Let's say pressure has to measure at this particular point P. Okay, so this simple tube which is open at one end, this end is open to the atmospheric pressure, and this is the point where the pressure has to be measured. So it's a simple glass tube. Okay, manometer do not require frequent calibration. That is correct. Okay, and manometers are easy to operate. 1 and 2 are definitely correct. Okay, but they are made of steel is not a correct thing, because generally they are made of glass tube. Okay, not made of steel. So this statement of made of steel, that is not correct. Okay, absolutely incorrect. The expression F is equal to mu A du by dy denotes. This is an equation of which of the following Newton's law? All are Newton's law. Newton's law of force, Newton's law of force, Newton's law of momentum, Newton's law of motion, Newton's law of viscosity. You know that what is Newton's law of viscosity? It says that shear stress is equal to mu du by dy. This is called Newton's law of viscosity. Shear stress is equal to shear force per unit area is equal to mu du by dy. So this is your Newton's law of viscosity. So from here you can calculate the shear force, which is equal to mu into A du by dy. That is obviously called as Newton's law of viscosity. The answer will be option D. Next question is, which of the following is a property of the fluid which makes it suitable to be used in the manometer? We know that in the manometer, the fluid that is used is called as manometric fluid. Okay, but this manometric fluid should be having a particular property. It's not that any kind of fluid can be used in the manometer. So there should be some property or some characteristics that manometric fluid should have. High surface density, high viscosity, high coefficient of thermal expansion, low viscosity. See, you have to tell the answer with respect to the manometer. See, in the manometer, what is the purpose of manometric fluid? Whatever is the pressure, because of the pressure difference, because of the pressure, the liquid will rise in the manometer, right? So high surface density, no. High viscosity. See, if the viscosity will be high, obviously that fluid cannot easily flow, right? So having high viscosity is obviously not correct. Thermal expansion. Thermal expansion is a property which is important with respect to thermometer. With respect to manometer, that is not correct. Okay. So the answer is option D, low viscosity. With respect to the option which are given, yeah, the answer is low viscosity, although there are some other properties like low vapor pressure. If the vapor pressure is low, if the density is high, okay, the fluid which is having low vapor pressure, high density, low viscosity, that is generally preferred for manometer. Okay. In a boundary layer at a certain location, the boundary layer thickness is 0.5 centimeter, displacement thickness is 0.15, and momentum thickness is 0.0585. what is the shape factor at this location? Now, what is the formula for shape factor? What is meant by shape factor? So the shape factor in context of boundary layer, the shape factor is equal to ratio of, can you tell me what is shape factor? Yes, any idea? It is ratio of displacement thickness to the momentum thickness. Okay, ratio of displacement thickness to the momentum thickness is known as shape factor. If you just put the values, you will get the answer. The delta displacement thickness is 0.15. This is 0.0585. Put the values, you will get the answer. Tell me what value you are getting. If you don't know the formula, you will get the wrong answer. 2.564 will be the answer for this question. Okay, so that is the case about the numerical questions. If somehow you don't know the formula, you will obviously even if the calculation is very simple, you will definitely get wrong answer. Okay, for example, many of you, if you will do momentum by displacement thickness, your answer will be wrong. If you do boundary layer thickness by displacement thickness, your answer will be wrong. So you should know the correct formula. Here boundary layer thickness is just given to confuse you. Okay, if you are using this value, you will just get confused. It is just given extra value for confusing you. Okay, it has no role for calculating the shape factor. Clear? Consider the following system: an electrical heater, a gas turbine, a reciprocating compressor. The steady flow energy equation can be applied to which of the above system? These are all different types of system, right? Steady flow energy equation, which is m into h1 plus v1 square by 2000 plus g into z1 by 1000 plus q is equal to m h2 plus v2 square by 2000 plus g into z2 by 1000 plus w. This equation, my friend, is steady flow energy equation. It is first of all, it is only applicable for open system, not for closed system. An open system under steady state condition. A gas turbine is an open system. It is an open system. An electrical heater is a closed system. Obviously, the current is passed through the heater, but it's not that mass transfer will not take place, right? Is there any mass transfer in the heater? No. Okay. Reciprocating compressor is an open system. So 2 and 3 are a case of open system. They are open system. The answer will be option D. Okay. So it is only applicable for an open system. Electrical heater, if it is there, no mass transfer take place in the electrical heater. Is there any mass transfer? No. If there is no mass transfer, it is a closed system. And if it is a closed system, you cannot apply steady flow energy equation for a closed system. It is only for an open system, right? In an experiment, a sample of wet steam is passed through a separating calorimeter at some instant means after some time, we can say at some instant of time, the mass of the water collected in the separator was 0.2 kg, while the amount of the steam which was condensed was 2.6 kg. What will be the dryness fraction of steam? Tell me. So what is dryness fraction? The dryness fraction is the mass of the steam, which is, here they are saying it is getting condensed, but it is the mass of the steam to the mass of the steam which is about to condense. Obviously steam will be condensed because condensation is done for the steam or vapor only, but plus mass of the water which is basically separated after getting condensed. So just put all the values, 2.6 by 2.6 plus 0.2, and you will get the correct answer. What is the answer you are getting? Tell me, everyone. Formula is important. If you solve it, you will get 0.928. Okay, option D. Clear? All right. So many mechanical engineers are following our session. I'm very proud. At least 5 students are there out of 807 subscribers. At least 5 are the active students, now 4, who are at least following our classes. Thank you so much, all the mechanical students. There used to be around at least 20 to 50, 20 to 30 minimum students which used to be come in my classes, but now it's just reduced to 4. I think many of the students have got selected, so they don't want to come to my sessions, or maybe it's that you're not liking my way of teaching. What's the reason? You can give our feedback also. You give your feedback so that we can, if you are having some chance of improvement, we can do that. Angle of diverging portion of the venturimeter is limited to 7 degrees. You know that in the venturimeter we have 2 sections in the venturimeter. One is called as convergence section, like in the case of a convergent divergent nozzle, followed by a divergent section like this. Okay, so that is how a venturimeter is. It consists of a convergence section followed by a divergent section like this. But the angle of divergence should be up to 7 degrees, not more than 7 degrees. Why? Because the flow deaccelerate in the diverging section. Deaccelerate means the velocity reduces. They are saying velocity reduces in the diverging portion and pressure increases. Hence, the fluid experience an adverse pressure gradient if divergence angle is more. Yes, that is absolutely correct. And this adverse pressure gradient causes boundary layer separation. So this reason is correct. Boundary layer separation will take place if the angle is more than 7 degrees. Flow separation takes place due to adverse pressure gradient when divergence angle is large. This is also correct. If the divergence angle is large or negative pressure, no. Option 3 is not correct. The right answer is option B. 1 and 2 is correct. Okay. Option B, 1 and 2 is correct. That is the reason why the angle of divergence should not be more than 7 degrees. It should be up to 7 degrees. Okay. In the Mollier diagram, when the entropy increases, the constant pressure line. In the Mollier diagram is the enthalpy and entropy diagram. It's enthalpy on the y-axis, entropy on the x-axis. Okay. And in this diagram, they are saying the constant pressure line when the entropy will increase. So these are constant pressure lines. Okay. And they are saying when the entropy increases, the constant pressure line in the superheated region converges to each other. This is a superheated region. Do you see they are getting converged or they are getting diverged? Superheated region, this is superheated vapor region. Are they getting converged or diverged? Tell me. In the superheated region, they are diverges to, yes, they are get diverges. This is correct. In the wet region, they are straight line. They are straight inclined line, not completely straight. You can call it as straight inclined line. Okay, straight line you cannot say, because straight line can be vertical also, horizontal also. It is actually straight inclined line. So option both 2 and 3 is correct. 2 and 3, that is option B will be the right answer for this question. All right. So this is the wet region. In the wet region, the constant pressure lines in the wet region are straight inclined lines. But in the superheated region, they are diverging to each other. Diverging means positive slope. Okay. Please look, please see this question. The figure below shows 4 points P, Q, R and S. I think there is some problem in the diagram. P, Q, R, S. Acha, okay, let's say they are point like this. P, then S, then Q, R. Okay. Although it should be P, Q, R, S. Fluid is allowed to flow over in the form of a lamina over the entire plate. So the fluid is flowing over the entire plates, and what is happening? A boundary layer is formed. This is a boundary layer is formed on the plate. Correct? This is a plate which is on which the fluid is flowing, and these are some points which are marked P, Q, PSQR. Okay. Question is, which of the following is the correct relation for the shear stress? Tell me. Now you know that shear stress is inversely proportional to the square root of x. What is x? X is called as distance from the leading edge. Distance from leading edge. And what is the meaning of distance from the leading edge? Leading edge is this. This is called leading edge. This is leading edge. So from leading edge, if you move in this direction, this is x. So as the x will increase, shear stress will decrease. So what is the correct relation for the shear stress? Obviously, shear stress for P will be more than shear stress for S, then Q, then R. So PSQR, decreasing order, PSQR, higher shear stress will be for P, then S, then QR. Okay, so the correct answer will be option B for this question. Is it clear to everyone? So remember this relation that shear stress is inversely proportional to distance from the leading edge, square root of distance from leading edge. As you move in the x direction, this is the leading edge. If you move in this direction, the distance will increase, this distance will increase, shear stress will reduce. So maximum shear stress will be at this point, and as you move in this direction, shear stress will decrease. Clear? A Carnot engine having efficiency is equal to 0.5 drives a Carnot refrigerator with COP is equal to 4. The energy absorbed by the refrigerator from the cold body for each kilojoule of energy absorbed from the source by the Carnot engine is. These kind of question can appear in your SSC JE or CBT2 or RRB JE CBT2 exam. Okay. We are having a Carnot engine, and that Carnot engine is driving a refrigerator. It is operating a refrigerator. Please read the question carefully. Draw the diagram, which it will be very much helpful. So this engine is actually drawing a refrigerator. It is operating a refrigerator. Okay. Carnot engine is operating a refrigerator. Now in this question it is being asked that efficiency of the engine is given. Let's say this is heat supplied. This is you have to tell the energy absorbed by the refrigerator from the cold body for each kilojoule of energy absorbed from the source by the Carnot. So this is, let's say this energy applied from the source is 1 kilojoule. If this is 1 kilojoule, it is asking what is this energy, this. Okay. Now main concept of this is that whatever will be the work output of the engine, that will be work input to the refrigerator. Is it clear to everyone? This is the concept here. Whatever will be the work output of the engine, that will be the work input of the refrigerator. Now efficiency of the heat engine will be work output divided by heat input. Heat input is equal to what? Each kilojoule of energy absorbed from the source by the Carnot engine. That means the source, this is the source of the Carnot engine, and from the source how much energy is getting absorbed? 1 kilojoule. So you can get work output will be equal to what? 0.5 into 1, that is 0.5 kilojoule. This will be the work output of the engine, and the work output of the engine is equal to work input to the refrigerator. Now COP of the refrigerator is equal to desired effect. What is desired effect of refrigerator? Q3 divided by work input, and work input is equal to work output of the engine, right? So Q3 divided by 0.5, and this is given as 4. So 4 into 0.5 will be 2. So answer will be 2 kilojoule. Clear? All right. Next question. The enthalpy of the wet steam after throttling from 1 to 2. You have to tell the enthalpy of the wet steam after throttling from 1 to 2 is how much. The process and the properties are given. Enthalpy at point A is given. At point A, the enthalpy is given. At point B, the enthalpy is given. X1 is given. Dryness fraction at point 1 is given. So my dear, you just notice here, as you know that point 1 is in wet region, right? It is in wet region. And enthalpy for steam in the wet region, how you find the enthalpy in the wet region? Tell me. The formula is HF plus X times of Hg minus HF. Remember this formula? Now, HF is nothing but HF is here what? HA. X is already given X1. Hg is Hb minus HA. Just put all the values, you will get the answer for enthalpy of the wet stream after throttling. But here in this question they are asking what? They are asking H2. After throttling they are asking H2. But you know that throttling H1 is equal to H2. If it is throttling, for throttling enthalpy is constant. So if you find the value of H1, you can get the value of H2. That will be same. So it will be 30 plus 0.4 into 250 minus 30. Solve it, you will get the answer. Tell me what value you are getting. Yes, everyone. Understood the concept or not? I promise you that I will take the kind of questions that will be important for your exam. They will be very much helpful for your SSC JE CBT 2 and RRB JE CBT 2 exam. You will definitely remember me. You will definitely remember me when you will find this question in the exam. You will say, sir, it's good that we have practiced this kind of question. If not, then God knows what will happen, right? So it's good that the selection of my questions says that I'm telling you for sure. If not, similar question will come in your exam. At least the same concept will come in the exam. Consider the following statement. A gas with a compressibility factor more than 1 is more compressible than a perfect gas. The x and y axis of the compressibility chart are compressibility factor on the y axis. First of all, let's read the statement number 1. A gas with compressibility. What is compressibility factor? Compressibility factor is PV by nRT. This is called as compressibility factor, right? Here Z is called as compressibility factor. Compressibility factor. Now it is saying that a gas having compressibility factor more than 1 is more compressible than perfect gas. Compressibility factor has one more formula. It is volume of the real gas to the volume of the ideal gas or perfect gas or ideal gas. If Z is more than 1, then what will happen? The volume of the real gas will be more than volume of the perfect gas. And you know it very well, what is the meaning of compression. If a gas is more compressible, it will be having less volume, not more volume. Here it is saying that a gas whose compressibility factor is more than 1 will be more compressible. No, it will be less compressible than perfect gas. So this statement is wrong. Are you getting my point? Because compression reduces the volume and increases the pressure. According to this, the volume is getting increased if it is more gas is more compressible. So this is wrong. 1 is wrong. So this and this will be wrong. The answer will be option A. See, statement based questions are very easy to solve, right? Because option A is not correct. Option 1 is not correct. So those options which are having option 1 in them will be not correct. So this is wrong. X and Y axis. Yes, compressibility chart. If you see a compressibility chart, on Y axis we have compressibility factor and on X axis we have reduced pressure. So this is correct. The first and second derivative, the pressure volume diagram, if you draw the pressure volume diagram for phase change, and if you see the critical point, at critical point of the pressure volume diagram, there is a point of inflection, and point of inflection means the first and second derivative will be 0 at critical point of a pressure volume diagram. Okay, so that is the meaning of statement. A Pelton wheel turbine operates with a speed of 600 rpm while the speed ratio is 0.44 and net head of 300 meter. What is the diameter of the wheel? So This particular question is, in this question it is said that speed ratio of the, it is given in this question. What is speed ratio? Speed ratio is basically U, speed of the turbine divided by blade speed of turbine divided by under root 2GH. Now this speed ratio is given to you 0.44. This blade speed you can find from here. This is under root square root of 2 into 9.81 into H is 300. Just solve it, you will get the value of U from here. Now what is U? U is the blade speed. The U is called as tangential blade speed, which is equal to pi dn by 60. This is called as tangential blade speed. Alright. So firstly find the value of U, then put it here, you will get the value of D. Okay, D is being asked in this question, diameter of the wheel. Please everyone try to solve it and tell me the answer. Just a second. See, I am using calculator, full use of calculator, because we know that you should get the right answer. So this will come out to be 33.75 meter per second, and 33.75 is equal to pi into D into N is 600 divided by 60. This will get cancelled out, so you can get it. So you will get D is equal to 1.07 meter. Okay. So do all the calculation, you will get the right answer. If you follow proper channel, then you will definitely get the right answer. Okay. If you have done the right calculation, you applied the right formula, and you use your calculation is correct, then definitely you will get the right answer. Next question. In a closed system, volume changes from 1 meter cube to 2 meter cube, and heat addition is 2000 kilojoule. The change in internal energy given the pressure volume relation is this. The pressure and volume are related like this. You have to find the change in internal energy. The heat addition is given, so it will be positive 2000, because in a closed system heat is supplied, it will be taken as positive. Now pressure is equal to 1000 times of volume. Whenever you find this kind of relation between pressure and volume, you have to find the work by using the relation integral of 1 to 2 PdV. This is how you are going to find the work. So pressure is 1000 into volume, so 1000 V dV. Integrated. Now integration is 1 meter cube to 2 meter cube. So the volume is changing from 1 meter cube to 2 meter cube. Just solve it. So this will be 500 V square by 2 after integration. 1 to 2 meter cube. Just solve it. You will get the answer. What is the value you are getting for work? Tell me. It will be 250. 4 minus 1, 250 into 3, okay, 750. So you will get 750 kilojoule as this. If you put all the values, Q minus W is equal to du. So you will get the right answer. What is the value you are getting? Oh, sorry, my mistake. Done something which is, I have already divided by 2, then why I'm, this will be 1000 into V square by 2, so this will be 500 into 2 square minus 1 square, 1500. So this will come out to 1500 kilojoule. Okay. Now you can solve this relation, you can get the right answer, which is 500 kilojoule. All right. So I have done 2 times division. Already I have divided by 2, again I was dividing by 2. Yes, everyone. I guess for some of the students question level they are finding level of question tough, but let me tell you, when you are in a process of practicing, you should practice all the type of questions that have a possibility of coming in the exam. Just practicing easy questions whom you have solved many times doesn't make you, is not called a good practice, right? If the specific enthalpy of a refrigerant at the entry and exit of the evaporator are given, and cooling required is 15 tons of refrigeration, then mass flow rate of the refrigerant is. So cooling required is how much? What is the cooling required? Cooling required is equal to, see, I can also bring easy questions for you. I have no problem. Okay. You can easily play ABCD there. Okay. You can easily solve those questions. But thing is that then learning will not happen. The correct learning will not take place. 15 tons. Now 15 tons can be also written as 15 to 3.5 kilowatt. Now cooling required is 15 to 3.5 is equal to mass flow rate of enthalpy at the entry and exit of evaporator. Enthalpy at the entry exit of evaporator. This is the formula. 15 into 3.5 is equal to mass flow rate. Hello Kuldeep, good evening. Coming in the session after a long time. Looks like you have been very busy. Very busy in the job. Okay, so you get mass flow rate is equal to 0.46 kg per second. Now 0.46 kg per second, you are not getting any option. So what you will do, because you are not getting mass flow rate in kg per second, so what you do, you multiply with 60. Multiply with 60, you will get 27.7 kg per minute. In kg per minute, you will get 27.7. Clear? Is it clear to everyone? So firstly, we try to solve it in kg per second, because we have taken 1 ton we have taken as 3.5 kilowatt, which is 3.5 kg per kilojoule per second. So the mass flow rate after calculating was 0.46 kg per second, but the option was not there, so we multiply by 60. Okay. And air is passed through the nozzle adiabatically to expand from initial pressure of 3 bar and temperature of 150 to final pressure of 1 bar and 30. That is, temperature is equal to 30. What is the work done by the nozzle? Tell me. What will be the work of the nozzle? Air is passed through the nozzle. See, it looks like a tough question. We are having a nozzle. If I draw a conversion nozzle will be like this. So the pressure and the temperatures are given at the entry and exit. All right. Work done by the nozzle. First of all, nozzle is adiabatic. There should be no heat transfer from the nozzle. And also nozzle does not produce any kind of work. So both the option D is the right answer for this question. Nozzle will not produce any kind of work and it is adiabatic. It works under the adiabatic condition. So the correct answer will be option D for this question. Next question. Next is a numerical question, and I know that after seeing this numerical question, many of you again will try to run away from the question. But let me tell you, I know I can't hold you in this session because it's a free session, but if you will continue to be in the session and you will follow these questions, your learning will definitely improve. Okay, you will get to know good concept, good questions I'm taking in these sessions. The following data is given at the entry of a steady flow system, that is open system. We are having an open system under steady state condition. At the entry, the pressure is given, velocity is given, internal energy is given, and specific volume is given. At the exit, the pressure is given, velocity is given, internal energy and specific volume is given. The system is considered to be adiabatic, that is heat transfer will be neglected. Potential energy changes will also be neglected. Okay, what will the power? In order to solve this question, I will be using the formula. Just a second, let me just have a complete blank slide for you so that I can solve this question. Just a second. Yeah, this is a question, right? I need a complete blank slide. Question is quite big. Okay, so steady flow energy equation is mass flow rate into H1 plus V1 square by 2000. Okay, plus G into Z1. Try to understand the question first. What is being asked and what you have to do there. So this will be the. अब कब सर हिंदी में सुनने को मिलेगा? I can say Hindi now also. I have not forgotten to speak in Hindi. मैं हिंदी बोलना भूला नहीं हूँ. Anas. Okay, I know how to speak Hindi, but वही है कि that here the sessions are basically in English language. Okay, because I told you that majority of the students understand English, so for them we are conducting these classes in English. The potential energy is zero and adiabatic. These are the conditions already given in the question. Now, next important thing that was there in the question is they have not given the value of enthalpy, right? So there are two ways you can solve this. Either you can find the enthalpy as enthalpy is equal to U1 plus P1 into V1. Either you can find the enthalpy H1 or H2 from here, U2 plus P2 V2, and then put in that equation. Because in this question they have given U1, that is 2000, plus P1, which is 600, into 0.4. From here you will get H1, and then likewise you can find the value of H2 also from here. Okay, you can use this relation and you can find the value of this is 1600 plus P2, that is 200, into 1. Solve it. So you can get the value of H1. Just a second. $2240, and this will be 1800. So put the values here. Mass flow rate is equal to how much? 5. 2240 plus what is the value of V1? V1 is 300. 300 square by 2000 is equal to mass flow rate, which is 5, into H2, which is 1800, plus what is velocity at the exit? Velocity at the exit and inlet is same. So if it is same, what will happen? You know it very well. What is going to happen? This will get cancelled out because velocity is same. So the power output will be equal to 5 into 2240 minus 1800. Very simple question. Okay. So just by finding the enthalpy, you will get the answer. So you will get 2200 kilowatt or 2.2 megawatt of power. So the answer will be 2.2 megawatt is developed by the 2.2 megawatt of power is developed by the system. Why by the system? Because work is positive. Because work is coming out to be positive, it will be work done by system. Clear? Understood everyone how you have solved this question? This thing would have been noticed early, initially only, that kinetic energy can be neglected because velocity is same. So this would have been neglected here only. Okay, we don't need to put this value. Okay, the time, this statement would have been like this, because velocity at the inlet and exit is same, right? So calculation would have been like this: 5 into 2240 is equal to 5 into 1800 plus power output. So you can get power output like this. Clear? Next, generator absorber are component of refrigeration system. Now you like these kind of question where when they will come, you will say, okay, generator absorber component are component of vapor absorption system. Yes. You will feel such a easy question. Generator, absorber, pump, they are component of vapor absorption system. Clear? The diagram factor is the ratio. What is diagram factor? Diagram factor is the ratio of area of the actual indicator diagram to the area of theoretical indicator diagram. Actual work done per stroke to the theoretical work done per stroke. Actual mean effective pressure to theoretical mean effective pressure. Any of the above mentioned. Well, all of the above statements are correct. See, if you say actual indicator diagram to theoretical indicator diagram, then also it is correct. Since actual area of the indicator diagram is equal to area of indicator diagram gives you what? It gives you net work done, right? It gives you net work done. So if it is area of actual indicator diagram to area of theoretical, so it will be equal to actual work to theoretical work. And because mean effective pressure is equal to net work divided by set volume. So mean effective pressure is also directly related to work. Area is also related to net work. So all the formula is same. So any of the above can be the answer. Okay. Neglecting the pump work, energy equation for vapor absorption system may be written as neglecting the pump work. So you know it very well that if you see a vapor absorption refrigeration system, in vapor absorption refrigeration system, we are having different components like generator. Now, since vapor absorption refrigeration system works in a cycle, it works in a cycle, and for a cycle net heat transfer is equal to net work transfer, right? Now what is the net heat transfer? Net heat transfer is equal to heat rejected minus heat supplied. Net work transfer is equal to work of pump. Now if you neglect the work of the pump, it will be 0, है ना? Now so we can say heat rejected minus heat supplied equal to 0. Where is heat rejected in the vapor absorption system? Heat is rejected where? Tell me. Heat is rejected in the absorber. Heat is rejected in the condenser. In these two components, heat is rejected. Okay. And where is the heat supplied? It is supplied in the evaporator. It is supplied in the, it is supplied in where? It is supplied in the generator. Okay. So we can write like equal to 0. So if it is equal to 0, either you can do what? Either you can say, you can keep it on other side. If you put this on the right side, what will happen? It will be evaporator plus generator minus absorber plus condenser. So this is also correct. This is also correct, and this is also correct. Are you getting my point? Because adding the heat, this is the total heat rejected. This is the total heat supplied. If you put a bracket here, okay, equal to 0. So if it is equal to 0, you can keep this on the right side. So this will be minus, then minus will come on this side. Are you getting this? Option D is the answer. Consider the following statements. To increase the stability of the empty ship, ballast are loaded at the bottom. What is ballast? Ballast is basically some kind of a loads. You can say you have also heard about the missiles, but we are not talking about the missile. Here we are talking about the not ballast missile, but we are talking about some load. Some load is kept at the bottom to increase the stability. And if you are talking about the stability of the ship, the stability of a ship, stability of ship is determined by metacentric height, right? Metacentric, because ship is a partially submerged body. It is a partially submerged body, so metacentric height will be deciding the stability of a ship, right? First of all, see this. First statement is to increase the stability, we are providing the ballast at the bottom of the ship. Okay, at the bottom of ship we are putting some load. Second is ballast. What is the reason? Ballast will increase the weight of the ship and reduce the metacentric height. If they are saying that if the ballast will increase the weight and that will reduce the metacentric height. So if the metacentric height will reduce, will the stability will increase. Both statements are contradictory. They are contradictory. Because if the metacentric height will reduce, then what will happen? What will happen to the stability? Tell me. Will reduce. So either option 2 is incorrect or 1 is incorrect. Out of these two, एक तो इनमें से incorrect है, right? That is 100% sure. Which is incorrect? They are asking correct statement. Which is correct? So both 1 and 2, see, neither 1 and 2 will not be correct because both are contradictory. Both, you cannot say both are incorrect. One of them is incorrect for sure. Both are not correct, that is also correct. We cannot say both are incorrect. Sorry, both are not correct. Tell me what can be the answer. To increase the stability of the empty ship, ballasts are loaded. Yeah, think about it. Use the brain. Does having the load, does putting some load on the ship will increase the stability, or it is something related to the stability? Tell me. Is there any relation of the stability with the load? Stability is related to the load. Is there any kind of relation with this? Just a second. Oh, just a second. Okay, so what will happen if you increase the ballast, if ballast are provided at bottom of the ship, metacentric height reduces. It will reduce the metacentric height. And if the metacentric height will reduce, what will happen? It will increase the weight of the ship and reduce metacentric. So option 2 is correct. Option 1 is not correct. So 1 is not correct, only 2 is correct for this question. Next is consider the following state. So Kuldeep will be happy that yes, he has got the right answer. Last question for today's session. Consider the following statements. Absolute 0 Kelvin can be achieved by using Carnot cycle. Absolute 0 Kelvin, that is 0 Kelvin temperature, is possible by using Carnot cycle. Is it possible by using Carnot cycle? PMM1 is a machine operating in a cycle having 100% efficiency. No work producing system can have efficiency more than that of Carnot. Which of these statements are incorrect? They are not asking about the correct statement, they are asking about the incorrect statement. Absolute 0 Kelvin can be achieved by Carnot. This is not correct. PMM1, what is a PMM1? PMM1 is a machine which gives you the work output without any work input. So for a cycle, efficiency of this will be work output divided by 0. Efficiency will not be 100%, it is infinite. This is also incorrect. This is correct. No work producing system can be having efficiency more than Carnot. So, but they are asking about the incorrect. So 1 and 2 are incorrect for this question. Okay, because they are asking incorrect statement, which are incorrect. So that's all for today's session. Rest of the question will be taken care of in the tomorrow's session. In tomorrow's session, I will take rest of the questions. But there is an information for all the students who are preparing for RRB JE exam. If you want to prepare with Resultant, there are three courses options. One is RRB JE CBT1 batch called Focus batch. One is CBT2 batch called AIM batch, and another is Mission batch for combined CBT1 CBT2. You can prepare from these batches. If you are having any query, you can just call on this number or you can mail us here. Okay. Also, do not forget to subscribe to our YouTube channel and press the bell icon. And if you have not liked today's session, if you find this session useful, please do not forget to like it and share it. And yes, please do follow this session, do come in the session. The session timing is deliberately I have taken 8 PM. Okay, 8 बजे रात को आपके लिए रखा गया है session. So those students who find it difficult to study in the morning or afternoon or evening, at least come in the night, right? Either have your dinner before 8 or after 9, and please do come in the classes just for 1 hour. You will definitely get something from these classes. Okay, so I will see you tomorrow. I will see you tomorrow at 8 PM. Timing is same. 8 PM. And do not forget to come to the session. And if you have not subscribed the channel, then please do it. Okay, thank you so much. Have a nice day. See you very soon. Thank you. Take care. See you tomorrow.